Gears inside a rear axle decide whether a car glides or grinds, and for most of the 20th century, nearly every one of those gears traced back to a single factory in Rochester, New York. The company behind it was built by an Irish immigrant who fled a starving country with nothing, and saved by his daughter, who joined the business at 11 years old after typhoid killed her brother. She became so famous that Henry Ford believed she had invented the company's greatest machine herself. Then, her own family pushed her out. This is the story of the Gleason Works. Before the story begins, a quick word. You are watching Trade Archive, where we document the companies and machines that built the industrial world. If that is the kind of history you are here for, take a moment to like this video and subscribe. It helps more than you would think. Now, back to 1851, and a 15-year-old boy standing on the deck of an emigrant ship leaving Ireland. William Gleason was born on April 4, 1836, in Borrisokane, a small market town in County Tipperary, Ireland. He was a child of the famine years, a decade when 1 million Irish died and another 1 million left. In 1851, at 15, William boarded a ship with his mother and brother and crossed the Atlantic toward America. The family settled in Rochester, New York, and the choice mattered. Rochester in the 1850s was one of the fastest-growing industrial towns in the country, a boomtown on the Erie Canal, where flour mills crowded the banks of the Genesee River and the high falls supplied free water power to anyone with a machine to turn. For a boy with nothing but his hands, it was the right city at the right moment. William had no capital, no formal education in engineering, and no connections. What he had was an aptitude for metal. He apprenticed in Rochester machine shops, learning the trade at the bench with files, calipers, and cast iron chips underfoot. An apprenticeship in the 1850s was not a classroom. It was years of hand-scraping surfaces flat, fitting bearings, forging tools at the fire, and absorbing the judgment that separates a machinist from a laborer, the feel for when a cut is right that no book can teach. William absorbed all of it. When the Civil War broke out, he carried that skill to Hartford, Connecticut, and went to work at Colt's Armory, one of the most advanced factories on Earth. Colt was mass-producing revolvers with interchangeable parts, a radical idea at the time, and every mechanic inside those walls was steeped in a doctrine of precision that most American shops had never seen. Gauges instead of guesswork. Fixtures instead of fitting. A part made in January had to match a part made in June, without a craftsman's file bridging the difference. William watched interchangeable manufacturing work at scale, and he carried the lesson back to Rochester like contraband. In 1864, he co-founded a machinery firm called Connell, Gleason and Graham. But partnership never suited him, and by 1865 he had struck out alone, opening his own machine shop in the Browns Race district of Rochester, on a ledge above the high falls of the Genesee River, in the same water power district where the city's flour barons had made their fortunes a generation earlier. The shop built general metalworking machinery, engine lathes and planers, the bread and butter of the era. The business absorbed the Kidd Iron Works and by 1876 operated simply under the founder's own name, William Gleason. A struggling immigrant shop among hundreds of struggling immigrant shops, distinguishable by nothing. That changed because of a problem that had frustrated machine builders for decades. Gears that transmit power between two parallel shafts are cylinders, and by the 1870s industry could cut them reasonably well. But the moment power has to turn a corner, the moment two shafts meet at an angle, you need a bevel gear, a gear shaped like a cone with teeth that taper from one end to the other. Every tooth on a bevel gear changes its profile continuously along its length, which means you cannot cut it the way you cut a straight gear. Shops of the era cast bevel gears rough and filed them by hand, or botched them on adapted machines. The results ran noisy, wore fast, and failed under load. An entire category of machinery, Everything from mill drives to farm equipment was throttled by the industry's inability to make this one component accurately. In 1874, William Gleason solved it. He designed and built the first commercially successful bevel gear planer, a machine that combined a planing action with an integral indexing head so that a cutting tool guided by the machine's own geometry could generate each tapering tooth correctly, then index the blank around and cut the next one, identically, again and again. The intelligence lived in the machine, and the machine did not get tired, did not guess, and did not vary. A gear that once demanded a master craftsman's full day could now be produced with repeatable accuracy by an ordinary operator. It didn't merely improve an existing trade, it created one. Precision bevel gearing became a product the world could actually buy, and William Gleason owned the means of making it. That original 1874 planer survives today in the collection of the Henry Ford Museum in Dearborn, Michigan, preserved as a founding artifact of American manufacturing. The first customers came from the world William already knew: farm machinery builders, mill owners, makers of anything where power changed direction. Then, in the late 1890s, the company caught its first genuine product mania. America went bicycle mad, and the most fashionable machine of the craze was the chainless bicycle, a shaft-driven design like the celebrated Columbia chainless, which replaced the greasy chain with a drive shaft and a pair of small, precise bevel gears at each end. Every chainless bicycle needed exactly what Gleason machines made, and orders poured into Brown's race. The boom collapsed within a few years, as manias do, and the lesson stuck. Ride each wave hard and be ready when it breaks, because the next application for a gear that turns a corner is always coming. The company had no idea how right that instinct was about to become. And here is a detail that says everything about how these machines were built. Gleason didn't assemble its machines from purchased parts. In 1888, the company established the Genesee Foundry Company, its own iron foundry, so that the massive machine beds and frames could be poured in-house from patterns the company controlled. The process started in the pattern shop, where craftsmen built full-size wooden replicas of every casting. Molders pressed those patterns into sand, poured in molten iron, and set the raw castings aside to season, letting the internal stresses of cooling relax before a single cut was made, because a bed that moves after machining is a machine that can never hold accuracy. In 1890 came the Gleason Tool Company, making the cutters and tooling the machines consumed, forged, hardened in the company's own heat-treating furnaces, and ground to final edge under the same roof. Finished castings were machined and then hand-scraped by craftsmen until their sliding surfaces were flat within fractions of a thousandth of an inch, a skill passed down through the company's own apprenticeship system. A Gleason machine was a Gleason product from the molten metal upward, and that vertical integration became the company's quality argument for the next century. In 1903, the foundry, the tool company, and the machine works were consolidated under one name that would become known in every industrial nation on Earth: the Gleason Works. But the company that built that empire very nearly died in its first decade, and its survival came from the least likely place imaginable. Through the 1870s, William was barely keeping the shop alive through one economic depression after another. His right hand in the business, and his presumed successor, was his son Tom. Then, in 1877, typhoid fever swept through Rochester. Tom caught it and died. William was wrecked. The shop's books fell into disorder, and the business drifted toward collapse while its founder grieved. His daughter Kate was 11 years old. Born on November 25, 1865, the same year as the company, she had grown up around the smell of cutting oil and the sound of line shafting. She asked to take over Tom's bookkeeping work, and William, out of desperation as much as anything, let her. It helped that the Gleason household was not a conventional one. Kate's mother, Ellen, was a friend of Susan B. Anthony, the suffragist whose activism was headquartered right there in Rochester, and the family accounts hold that Anthony's circle shaped William's willingness to bring a daughter into a machine shop when no one else in the industry would have considered it. So an 11-year-old girl sat down at the ledgers of a failing gearworks and started balancing them, working the desk before and after school, teaching herself machine engineering from library books at night. The arrangement began as an emergency. It became the company's future. She never stopped climbing. In 1884, Kate Gleason became the first woman to enroll in the mechanical arts program at Cornell University, the first woman admitted to study engineering there. The company pulled her back before she could finish the degree because it needed her too badly, and by her mid-20s, she was the firm's secretary-treasurer and, more importantly, its chief salesperson. Think about what that job meant. Selling heavy machine tools in the 1890s meant boarding trains with a case full of drawings and price books, walking into foundries and factories run entirely by men, and convincing hard-nosed shop owners to spend a fortune on your machine instead of a competitor's. The novelty of a woman selling gear planers got her through doors that stayed shut to other salesmen, and the depth of her technical knowledge kept her inside once the questions started. Kate did it across America. And then she did something almost no American machine tool executive of any gender was doing. She sailed to Europe, alone, and sold Gleason machines in England, Scotland, France, and Germany, calling on the great engineering works of the Old World and walking out with orders. The export markets she opened transformed a Rochester shop into an international name. Her fame grew to the point of distortion. Henry Ford, whose company would become one of the great consumers of Gleason equipment, publicly credited Kate with the bevel gear planer itself, calling it the most remarkable machine work ever done by a woman. It wasn't true. Her father had invented it before she reached her teens, and Kate said so, but the myth traveled anyway. Buyers wanted to meet the famous Miss Gleason of Rochester. Orders followed her. For roughly 35 years, she was the face of the Gleason Works to the outside world, and the company's global reach was substantially her creation, which makes what happened next one of the coldest turns in American industrial history. But before we get there, the machines themselves were about to meet their destiny, because at the turn of the century, a new customer arrived that would swallow everything the Gleason Works could build. The automobile. Every car ever made has to solve the same geometric problem. The engine's power runs along the length of the vehicle, and the rear wheels spin across it, which means the power has to turn 90 degrees inside the rear axle. That's a bevel gear's job. The horseless carriages multiplying across America at the turn of the century were, from Gleason's point of view, bevel gears on wheels. And when Ford's assembly lines began pushing automobile production from thousands of cars a year toward millions, every single one of them needed a differential, and every differential needed gears cut on somebody's machines. The company positioned itself directly in the flood path. In 1905, anticipating the boom, the Gleason Works moved out of Brown's Race into a massive new purpose-built plant on University Avenue in Rochester. Long brick bays filled with overhead cranes, its own foundry operations, heat-treating furnaces, tool rooms, and assembly floors laid out so that iron could enter one end as raw castings and leave the other as finished gear machines. It was a factory designed to build factories' machinery, and it remains the company's world headquarters more than a century later. But the straight bevel gears of the era had a flaw that every early motorist knew personally. They howled. Straight teeth engage all at once, tooth slamming onto tooth, and at automobile speeds, the rear axle of an early car whined and hammered like a coffee grinder. The company that could make a quiet axle would own the industry. Therefore, in 1913, James E. Gleason, William's son and the company's engineering leader, working with engineer Arthur L. Stewart, developed the machinery to generate spiral bevel gears, gears whose teeth curve across the face of the cone. The machine that produced them was a mechanical marvel in its own right. Rather than copying a template, the generator rolled the gear blank against a rotating cutter in a precisely coordinated motion, as if the blank were meshing with the teeth of an imaginary perfect gear, so the correct tooth shape emerged from the geometry of the machine's own movement. Curved teeth engage gradually, sliding into contact instead of slamming, and the difference in noise and strength was immediately obvious to anyone who drove behind them. The spiral bevel gear made the modern drivetrain possible. It also started a war. Engineers at the Packard Motor Car Company had been developing spiral bevel gears of their own, and Packard held patents on the gear design. Gleason held the patents on the machinery that could actually mass-produce such gears. Two industrial titans, each holding half of the future and neither able to move without the other. Infringement claims flew, and the dispute carried the threat of freezing quiet axle production across the entire American auto industry, just as that industry was learning to run. Both sides eventually recognized the arithmetic of mutual destruction and settled out of court. Packard kept its rights in the gear design. Gleason kept the machines. And since every automaker on Earth needed the machines regardless of whose design they cut, Gleason walked away holding a practical monopoly on the equipment behind every automotive rear axle in existence. The gear design was a product. The machine that made it was the industry. In 1916, the company helped found the American Gear Manufacturers Association, literally writing the standards for the business it dominated. Yet 1913, the year of the company's greatest technical triumph, was also the year the Gleason family broke. Kate was now competing for authority with her brothers inside the firm, above all with James, who ran engineering and operations, and who, by every account, had no intention of sharing command of the company's future with his sister. She held the title of secretary-treasurer and the loyalty of customers on 2 continents. He held the shop, the drawings, and the family's confidence. Whatever combination of family friction and plain gender prejudice drove it, the outcome was the same. The woman who had kept the books at 11, opened Europe at 25, and carried the Gleason name around the world was pushed out of the business she had helped save. She resigned around 1913, and the company's official story would spend decades sanding the edges off that departure. Kate's answer was to become more famous than the company. In 1914, a court appointed her receiver of the bankrupt Ingle Machine Company in East Rochester, reportedly the first time an American woman had held such an appointment, and she rebuilt a firm carrying roughly $140,000 in debt into a business valued at around $1 million. That same year, the American Society of Mechanical Engineers admitted her as its first woman member. In 1917, when the president of the First National Bank of East Rochester left for war service, Kate took over the bank, becoming the first woman to lead a national bank without a family connection to it. Then she turned to the post-war housing shortage. Borrowing the mass production logic she had watched at Ford's factories, she engineered a system for pouring low-cost concrete houses and built a development in East Rochester called Concrest. Modest fireproof homes for working families, laid out like a French village. The American Concrete Institute admitted her as its first woman member. When she died of pneumonia on January 9, 1933, she left an estate of about $1.4 million, most of it to charitable and educational causes. 65 years later, in 1998, the Rochester Institute of Technology named its engineering school the Kate Gleason College of Engineering, the first engineering college in America named for a woman. The company had erased her from its leadership. History reversed the decision. Back on University Avenue, the machines kept advancing without her. In the mid-1920s, a Swiss-born Gleason engineer named Ernest Wildhaber, who would be credited with 279 United States patents across his career, one of the largest totals of any inventor in mechanical engineering, developed the hypoid gear, filing his key patents in 1926. A hypoid gear looks like a spiral bevel gear with one crucial difference. The pinion is offset below the center line of the ring gear, which means a car's drive shaft can sit lower in the chassis. Lower drive shaft, lower floor, lower center of gravity. And by the late 1920s, hypoid axles were spreading across the American automobile, reshaping how every car since has been packaged. Around the same technology, the company kept stacking proprietary processes with trademarked names like Formate and later Revicycle, each one shaving seconds off a production cycle that Detroit repeated millions of times a year. William Gleason lived to see the beginning of that era. The famine emigrant from Tipperary died in 1922 at 86, and James E. Gleason took the presidency that same year. He would hold it until 1947 and remain the company's chairman until his death in 1964, a span in which one family's judgment steered the world's gear technology for the better part of a century. Then the machines went to war. When the United States mobilized for the Second World War, nearly everything that moved under armor or wing needed precision gears, and the machines that cut those gears came overwhelmingly from Rochester. The University Avenue plant ran around the clock, and by the company's own wartime record, Gleason equipment produced gearing for the M4 Sherman tank's drive systems, for aircraft, and for naval propulsion. A Sherman's final drives had to survive 30 tons of tank lurching across broken country, and the gears inside them were cut to tolerances measured in 10,000ths of an inch on machines designed in peacetime for family sedans. The company's records also reach back further, placing Gleason-cut gearing in machinery used to build the Panama Canal decades earlier. From the locks of the canal to the treads of a tank column grinding toward the Rhine, wherever American industry needed power to turn a corner, the same factory kept showing up. Out of the war years came one of the company's quietest and most extraordinary products, the Curvic coupling. A Curvic coupling is a set of precision-ground face teeth that lets two rotating parts lock together in perfect alignment, center themselves automatically, and transmit enormous torque, so exact that engineers use it to join the spinning stages of jet engines, where a misalignment of a few 10,000ths of an inch would shake a turbine apart. Those couplings carried Gleason workmanship into the jet age, and eventually beyond the atmosphere entirely. Curvic couplings flew in hardware for the Apollo program, which means the same company that fixed the squeal in a Model T-era rear axle had components riding to the moon. 90 years from a shed above the Genesee Falls to lunar orbit. But things are about to take a dark turn. Through the 1950s and the 60s, Gleason sat comfortably at the top of a golden age. American machine tools were the best in the world. The Big Three were devouring gear machines as fast as Rochester could build them, and Gleason equipment was cutting gears for far more than cars, for farm tractors, mining trucks, helicopters, machine tools, and ships in plants on every industrialized continent. Salesmen no longer had to explain who Gleason was. In the gear trade, the name functioned the way Xerox did in copying, spoken as if it were the product itself. A job at the Gleason Works was a job for life, the kind of employment men handed down to their sons, and the company's apprenticeship program remained one of the most respected trade educations in American industry. But by the late 1970s, the ground was shifting. Japanese and European machine tool builders, rebuilt after the war with newer plants, patient capital, and government backing, came into the American market with capable machines at prices Rochester couldn't touch. A strong dollar made imports cheaper still, and American buyers, squeezed by their own recessions, stopped paying a premium for the name on the casting. Then the downturn of the early 1980s hit. Detroit's orders collapsed, and the American machine tool industry entered a contraction it would never fully reverse. Storied builders that had equipped 2 world wars died by the dozen, absorbed, liquidated, or simply switched off. Gleason survived, but survival was ugly. The company posted losses, froze pay, eliminated overtime, and cut deep into a workforce that had thought of itself as permanent, and the layoffs landed hard in a city already watching its industrial base bleed out. For families who had spent 3 generations inside the University Avenue plant, the idea that the Gleason Works could shrink was a kind of heresy. It shrank anyway. Across the same years, Rochester watched Kodak stumble and its other manufacturing anchors buckle, and the question being asked in Washington hearings about the entire American machine tool sector, whether the country could still equip its own defense industry, was being asked on shop floors in Rochester in far more personal terms. Men who had scraped machine ways for 30 years were walking out the gate with boxes. The company that had never known a world where it wasn't winning now had to learn how to survive losing. The era forced another reckoning too. A century of heavy manufacturing leaves its residue in the ground, and in the early 1990s, the Rochester plant came under state environmental oversight for contamination that included PCBs found in the quench oil of its heat-treating operations, toxic industrial fluid that had accumulated through decades of hardening gears and cutters, and that now had to be drained and remediated under New York State supervision. But Gleason's answer to the crisis was the same as it had been in 1874. Build a machine nobody else could. At the end of the 1980s, the company introduced the Phoenix, its first fully computer-controlled bevel gear-generating machine, collapsing the elaborate cams, cradles, and mechanical adjustments of the old generators into servo motors and software. A setup that once took a skilled operator hours of wrench work became numbers entered at a keyboard. The name was not subtle, and it was not wrong. Through the 1990s, the company rebuilt itself around a new strategy it called Total Gear Solutions, buying its way into every corner of gear making. Munich's Karl Hirth came aboard in 1995, Germany's Fodder in 1997, bringing cylindrical gear machines, and in later years came Metrology Systems, the Swiss design software firm KISSsoft in 2017, and in the company's 160th anniversary year of 2025, the Intra Group and Italy's Fubri. Each deal widened the moat. None of them, however, was the real drama of the era. That came in 2000, when the Gleason family took its company back. Gleason had spent decades as a publicly traded corporation, answering to shareholders who watched a deeply cyclical machine tool builder's stock with limited patience. Every downturn brought the same pressure: cut deeper, sell faster, explain the quarter, and a company whose products took years to develop and decades to pay off was being graded in 90-day increments. James S. Gleason, the family's standard-bearer, who had led the company since the early 1980s and carried the name on the front door, decided the firm's long-horizon engineering culture and Wall Street's quarterly appetite could no longer share a building. Partnering with the private equity firm Vestar Capital Partners, the Gleason family and management moved to buy out the public shareholders entirely. Deals like this are never quiet. Taking a company private means convincing thousands of strangers to sell you their piece of it, and every one of them wants to believe the insiders know something the price does not show, which is precisely why the insiders are buying. The offer landed at $23 a share, a transaction valued at roughly $332 million, and in 2000, the Gleason Corporation went private. It was a bet that the company's future was worth more than the market said it was, made by the people who knew it best, with their own name and their own money on the line. If the machine tool cycle turned against them, there would be no shareholders left to absorb the pain, only Gleason's. 135 years after William opened his shop above the falls, the company answered to a Gleason again, and to no one else. What privacy bought was patience. A private Gleason could pour money into a machine program that would not pay off for a decade, ride out a downturn without staging a quarterly performance for analysts, and keep buying the pieces of the gear world it did not yet own without explaining every move. The strategy of the following 2 decades, the acquisitions, the software, the measurement systems, all of it ran on capital that no longer had to apologize for the machine tool cycle. The public markets had funded Gleason's growth for a generation. The family decided the next century would be funded on its own terms. And the old instinct for legal warfare hadn't dulled either. In the late 1990s, Gleason hauled two of its most formidable foreign rivals, Switzerland's Borrisokane and Germany's Liebherr, into federal court in the Western District of New York, accusing them of infringing its patent on computer-controlled bevel gear generating technology, the crown jewels of the Phoenix era. The stakes were the same as they had been against Packard 80 years before. Whoever controlled the machines controlled the market, and Gleason had no intention of watching competitors sell its own breakthrough back to its own customers on American soil. The litigation ground on into the 2000s through motions, expert reports, and federal rulings, expensive, grinding, and entirely in character. Patent suits at this level are wars of attrition, fought in filings rather than showrooms, where the side that blinks first hands its rival a license to compete. Gleason had fought this exact war against Packard when the technology was cams and cradles, and it fought it again when the technology was code. A company that had spent its whole existence turning geometry into property was still defending the machines with the same ferocity it used to build them. Today, the Gleason Works still operates from 1000 University Avenue in Rochester, the plant it moved into when Theodore Roosevelt was president, now led by Chief Executive John J. Perotti and flanked by factories and operations in Germany, Switzerland, India, China, Mexico, and beyond. The machines have kept their edge. The Phoenix line's descendants cut and grind bevel gears under full computer control. Laser-based inspection systems check gear teeth at production speed so that every part, not just a sample, can be verified. And design software, machine and measurement now talk to each other in a closed loop, where an inspection machine that detects a microscopic error sends the correction straight back to the cutter. The newest frontier is the electric vehicle, where there is no engine noise left to hide a whining tooth. And Gleason engineers now shape gear surfaces at the microscopic level to control the very sound a drivetrain makes, tuning the acoustics of a gear mesh the way earlier generations tuned its strength. There are very few companies anywhere on Earth that have led the same technology continuously since the age of the water wheel, and fewer still doing it from the same address. The product has changed for 160 years. The mandate never has. William Gleason crossed an ocean with nothing and solved a problem the industrial world had given up on. Kate Gleason saved his company, was cast out of it, and built a legend that outgrew the family that rejected her. James Gleason's machines put the quiet in every car you have ever ridden in. One family, one factory, and a single geometric problem: how to make power turn a corner, carried from the age of water wheels to the age of electric drive. That factory is still standing, and it is still cutting. If stories like this one belong in your feed, subscribe to Trade Archive. The next video is waiting.